We're going to talk about parabolas now. What is a parabola? A parabola is the set of all points equidistant from a point and a line. The set of all points equidistant from a point and a line. So let's take a look at what that actually looks like. So I have a parabola. Notice that this parabola is graphed sideways. We'll talk about why and what that might look like um, based on what we've learned in the past, because obviously what we've talked about in the past is all of our parabolas have either opened going up or going down. And so now we're going to talk about parabolas that open to the left and right also. But basically what we're looking at here is um, here's a point, this point in orange, and here's a line that's in red. And basically what I'm saying is that every point on the parabola has the exact same distance from the orange point and the red line. So every point on the parabola has the same distance from the orange point and the red line. And that's true if I um, widen the distance. So if I make the orange point and the red line further apart, closer together, that changes the shape of the parabola. But in either case, notice that the distance from the parabola or from the parabola to the orange point is the same as the distance from the parabola to the red line. And that's also true uh, in this case as well. So if I have the parabola where the orange point is on the right side of the red line, uh, or in any case like this, notice that the distance here ends up being the same from the orange point to the parabola and the red line to the parabola. I call that point the focus. So that was the orange point in our diagram. The orange point in our diagram is called the focus, and the red line in our diagram is called the directrix. So if we go back and look at that again, the red line is called the directrix, the orange point is called the focus. Note that neither the focus nor the directrix is actually on the parabola. So that's important to be aware of. We still have all the same vocabulary words that we had for a parabola earlier in the year. We'll figure out x-intercepts, we'll figure out y-intercepts, we'll figure out the vertex of the parabola. Um, but we now have a couple new vocab words, focus and directrix. So here are some equations of parabolas. Notice that if it opens in the y direction, the y value will not be squared and the x value ends up being squared if you multiply everything out. So this would be what we used to call standard form, and we still do call standard form. This one right here we call factored form. And the one at the bottom, which is very similar to the one that we see third. So the one at the bottom we called vertex form. Okay, factored form we also could call intercept form because we can figure out what the intercepts of the graph are. And so these are things that we learned back in chapter 3, our third unit of the year. Now, notice that vertex form gives us the vertex. So the vertex in vertex form is going to be h comma k in both cases, whether it opens in the y direction or x direction. In factored form, we have intercepts. So the intercepts over when it opens in the y direction are m comma 0 and n comma 0. But if it's opening in the x direction, our intercepts are 0 comma m and 0 comma n. That's because if it's opening in the x direction, we're going to have possibly two y-intercepts, whereas if it opens in the y direction, we have potentially two x-intercepts. Also, just like in when we learned about parabolas, first of all, there may be sometimes where these parabolas don't actually intercept the x or y axis at all. If it's opening in the y direction, it will for sure have at least one y-intercept. If it's opening in the x direction, it will for sure have at least, well, I shouldn't say at least. If it's opening in the y direction, it will have exactly one y-intercept. If it's opening in the x direction, it will have exactly one x-intercept. Um, the difference is, depending on where the axes lie, if it's opening in the y direction, it may have 0 x-intercepts or 1 x-intercept or 2 x-intercepts. Likewise, if it's opening in the x direction with the picture as shown, it could have 0 x-intercepts, 1 x-intercept, I'm sorry, 0 y-intercepts, 1 y-intercept, or 2 y-intercepts. And that's because if we have this situation, this case it has 0 y-intercepts, this case it has 1 y-intercept, in this case it would have 2 y-intercepts. So that's stuff that we learned already. And then standard form is what it is. So a couple more pieces of information that you might want to know. We can actually use the information that we got from the focal length. We can use the information that we got from the focus and the directrix to figure some stuff out. So that A value that we were talking about, so notice where all the A's are, I can actually replace that with 1 over 4p. Okay, so just for example, if I had something that's opening in the y direction, so y equals a times x minus h squared plus k. I can replace a with 1 over 4p, and what 1 over 4p tells me is that tells me that can give me a clue as to how far away the focus and the directrix are from the parabola, especially the vertex of the parabola. So, for example, let's say I have the equation y equals 2 times x minus 3 squared plus 10. I know that the vertex is at 3 comma 10. And I know, based on what I learned in previous chapters, that there's some sort of vertical stretch of 2. But now what I can do is I can take that 2, and I know that 2 is equal to 1 over 4p. So if 2 is equal to 1 over 4p in this example, what that basically tells me is if I solve for p, so 4p equals 1 over 2 and then divide by 4, I get p equals 1/8. What that tells me is that the distance from the focus to the vertex is 1/8. That also tells me that the distance from the vertex to the directrix is 1/8. And whether it's positive or negative tells me where the focus and where the directrix are. So since this number was positive, that means that since this is a parabola that's opening up, what I have is I have the focus is always on the inside of the parabola, and the directrix would be down here in this case. And each of those distances is 1/8. Okay, so here's an example. I guess this number is 2 again. So really quickly, I'll give you a different example with a p later after we're done. So if we take a look at this, the first thing we're noticing is that it's an x equals graph. So x equals something with a y squared. That means that it's going to open in the x direction, and I see that I have a -2, so that means my graph will definitely open like this. I can find the vertex. I can either find the vertex by completing the square. So I'll do that really quick just to remind us of how to complete the square with a number in front in case we have forgotten. So I can go -2 y squared minus 4y plus blank minus 6, and then I'll be adding 2 times whatever I put just to kind of keep it balanced. So I have -2 times y minus 2 squared, and then -2 squared is 4. So I really added -8s to this problem. So that means I have to add +8 to keep it balanced, since I'm adding and subtracting the same thing from the same side. So I end up with -2 times y minus 2 squared plus 2. That means that my vertex in this problem is at 2 for x and 2 for y. So my vertex is at 2, comma 2. I will be opening left, and I can figure out where my focus and directrix are, but I can also do some calculations based on things that I learned in the past. So this -2 is an a value, since a equals -2. What that means is I could make a t-chart, or what I learned back in the day was if a equals -2, then if I went over 1, I go up, down 2. If I go over 2, I go down 4 times 2, which is 8. So just a reminder, the typical parabola pattern is over 1, up 1, over 2, up 4, over 3, up 9, because I'm squaring everything. But in this case, since this is actually an x equals, I'm not over 1, up 1, over 2, up 4. I'm actually uh, over, I'm actually going up 1, over 1, up 2, over 4, up 3, over 9. So these in this case are the y's and these are the x's, because this is an x equals graph. So I'm going to take all of my x's and I'm going to multiply them by -2. So I go up 1 to the left 2. And since it's symmetric, it will go down 1 to the left 2 also. If I go down or up 2, I will go to the left 8. That is because I end up having this -2, which means it's going to the left, and I'm multiplying all these values by -2. So this is what my parabola looks like in this particular case. We can find the x-intercepts and y-intercepts by just looking at the graph now. So the y-intercepts in this case are going to be 0, 1, and 0, 3. And the x-intercept is at -6, 0. But we can also find these things from other ways. For example, the x-intercept is definitely going to be -6 because I knew that just from the original problem. If I substituted 0 in for y, I'm going to get -6 for x. I also could have factored the problem. So instead of completing the square, what I could have done was I could have factored the problem, and I could have had, notice that -2 is the greatest common factor. So I have y squared minus 4y plus 3. I could have factored this into -2 times y minus 3 times y minus 1. And that would mean that what makes x 0 would be when y is equal to 3 or when y is equal to 1. So those would have shown up there. The axis of symmetry is exactly what it was in when we learned about parabolas before, except in this case, it's going to be a horizontal line. So this is a y equals line in this case. So I have y equals 2. That makes sense because my vertex is at 2, 2. Now, the focus and directrix, let's talk about that. Since -2 is equal to 1 over 4p, that means that I want to get p by itself. So p equals -1/8. And that means my focus is going to be 1/8 to the left of the vertex, and my directrix is going to be 1/8 to the right of the vertex. So my directrix will be around there. So if I want to have a focus point, notice that the x's are changing here. So I would have 2 minus an eighth, or 1 and 7/8. That's 15/8, comma 2. So it's 2 minus 1/8 for my x value of the focus. And then the directrix is going to be 2 plus 1/8. And notice this is a line. So the directrix has to be an x equals or y equals line, depending on whether it opens sideways or up and down. So that's that. All right, write the equation of the parabola with focus at 5, -4, and directrix at y equals 8. So notice that the directrix is y equals 8 here. Because the directrix is y equals 8, if the directrix is going this way, That means that I'm going to have a parabola that opens up or down. Since my focus is at 5, -4, that means that my parabola has to be opening down because the directrix is above the focus. So the vertex is going to be directly in between the y values that we are given. So it's going to be between the y values because the directrix is a y equals line. Whereas in this problem, notice that because the focus and the directrix had x value changes, that means that it's opening in the x direction, so it's opening either left or right. So in this problem, it's going to open up or down, um, and -4 plus 8 divided by 2 is going to give us the y value where my focus is. I'm sorry, the y value where my vertex is. So my vertex y value is at 2, and the x value is 5 because the x value won't change. So 5 comma 2. Again, the x value won't change because in this case, this is going to be a y parabola. So it's going to look something like this. Um, the wideness of how it opens is related to how far apart the focus and the directrix are. So P in this case is going to be the distance from either the focus to the vertex or the vertex to the directrix. So in either case, this length is 6. So that means P is 6. So I'm going to do 1 over 4p. And notice I have to make this negative because it's opening down. So because it opens down, that means that this is going to be a negative 1 over 4p. So I have y equals negative 1 over 4p. Since p is 6, this is going to be negative 1 over 24. Since my vertex is at 5, 2, that means I have x minus 5 squared plus 2. So that's something that I learned way back in a previous chapter. Um, so notice that in this case, my p is big, so that means my a value is small, which means that if I actually graphed this relatively accurately, um, this uh, this is going to be a very wide parabola, very very wide parabola, because 1 over 24 is a pretty wide number, um, a pretty small number, which leads to a wide parabola, and that is your notes on parabolas.